Okay, this is going to be my final video for now. We are talking about problem type F from our review. That is objective 5.5, multi-step trig equations using the reciprocal identities to get rid of unlike terms. These are the 5 reciprocal identities. We're not going to use these too much right now, but these 3 we should be pretty familiar with all the work we've been doing solving different trig equations. So if you are having trouble with solving just the basic trig equations, go back and watch some of the other videos. We are only talking about substituting reciprocal identities in this video. So that is the only part we're going to focus on. I just want to look at, let's do 2 problems. Let's do 6 cosecant theta equals 2 sine theta plus 4, and we will do 4 tangent theta minus 7 cotangent theta minus 3 equals 0. I believe these have both been homework problems at some point or another, but a little extra review of this won't hurt. The problem with each of these problems, there's nothing squared right now, so we couldn't factor even if we wanted to, but this has a cosecant and a sine. We only want to have one of them, whereas this one has a tangent and a cotangent. We only want one. Sine and tangent are probably the 2 simpler of the 4 that you see, so we're going to try to turn this into sine and this into tangent. So let's start with number 1. 6 cosecant theta equals 2 sine theta plus 4. I want this cosecant to be in terms of sine, and we know that cosecant is equal to 1 over sine. So we will say 6 times 1 over sine theta equals 2 sine theta plus 4. And now let's go ahead and rearrange this problem. I want to put everything on one side. I'm just going to subtract this all the way to the end. So we will say, and I'm going to move this to the other side too, 2 sine theta plus 4 minus, because I'm subtracting this from both sides, 6 times 1 over sine theta equals 0. So hopefully I didn't lose anybody. I just rearranged this equation. I didn't really change anything, but I moved that to the other side and then spun the equation around. So 0 was on the right. I don't want this fraction. So what I want to do now is I would like to distribute a sine theta to every term. Of course, sine theta times 2 sine theta gives me 2 sine squared theta. Sine theta times 4 gives me plus 4 sine theta. And sine theta times negative 6 sine over, or negative 6, 1 over sine. Sine theta times 1 over sine of theta will cancel each other out. And that is the pattern you're going to notice on all of these problems. We're going to turn it into a quadratic. So this became sine squared, this became 4 sine theta, and this 6 just became a 6. And from here, you can check for a GCF, and then you will factor or use the quadratic formula. And that was type C and type D, if you would like to go back to those videos and watch. But I just want to make sure we get this process down. Let's look at that other problem. So problem 2 was 4 tangent theta minus 7 cotangent theta minus 3 equals 0. I want cotangent to be tangent, and we know cotangent is equal to 1 over tangent. That is one identity that it has. That's the most useful one for this problem. So let's rewrite this. 4 tangent theta minus 7 times 1 over tangent theta minus 3 equals 0. To get rid of that fraction, I need to distribute the denominator to every term. So I will distribute tangent theta to all of my terms. And I can do that because I'm doing it to both sides. It's just tangent theta times 0, still 0, so it doesn't change anything. So that gives me 4 tangent squared theta minus 7. Well, the tangents will just cancel out. And then tangent theta times negative 3 is minus 3 tangent theta equals 0. And we can rearrange this, make it look a little nicer. And to finish it from there, this is exactly like problems type C or D. We will either solve by factoring or the quadratic formula. And there are videos for both of those. And I encourage you to go back and look if you're still having trouble.